All right, and welcome back to the fourth lead-in lesson of our 2021 School-Wide STEAM Challenge. In this lesson, we're going to actually look at all the nets and the forms that you can create as part of your Dodecahedron. The slides you're going to see are directly from the instruction manual, which is found on the school's website. And we'll tell you a little bit about each of the 10 forms. Now, the 10 forms come in two categories. The first 5 you're going to see are what are called recommended. They're a little bit easier to assemble and kind of a nice variety to create a pretty decent Dodecahedron. The last 5 forms you're going to see are what we call elective nets. They're a little bit trickier to assemble. They'll take more time and more patience, but they might add a little bit of pizzazz and whimsy to your Dodecahedron. So let's meet the 10 forms. So the first form is the cube, and you've seen this one a lot used before. Basically 6 square faces. A cube is also called a hexahedron. Why? Because, well, it has 6 sides or 6 faces, and the prefix hex means 6. And so we can say that, well, all cubes are hexahedrons, but not all hexahedrons are cubes. It's like saying all hamburgers are sandwiches, but not all sandwiches are hamburgers. So enough of that one. All right, next is the tetrahedron. This has 4 triangular faces. Sometimes it's also called a triangular pyramid because it has a triangular base that it sits on, and then it has 3 triangular sides. This in real life is actually the molecular structure of the methane molecule, which is CH4. Imagine you have a carbon atom, kind of one carbon atom sitting right in the middle. If I were to look right inside this thing, there's a carbon atom sitting right in there. And there's 1, 2, 3, and then 4 hydrogen atoms in the corners. Next one is the hexagonal prism. So it has 2 hexagonal faces. And then you can think of it as it's got 6 kind of rectangular sides to it. That's kind of the definition of a prism. The ends, you can think, the top and the bottom are a polygon, and then the sides are just either squares or rectangles. Where do you see this one in real life? Well, if you have like a hex nut, that'll go with a bolt. It's the same shape. And a number 2 pencil, not the round ones that roll off your desk. But if you kind of were to slice a number 2 pencil, it's going to look exactly like a hexagonal prism. All right, next one is a square pyramid. So it's got a square base to it, and it's got 4 triangular sides to it that all meet at a common point that would be called the apex. And very similar to the pyramids of Egypt, looks just like it. And the nice thing about these pyramids is they're actually very sturdy. Why? Because in engineering, the triangle is the strongest shape. If you ever drive over a bridge, look at the shape that all the beams make, those gaps. They make triangular shapes. The next one is the triangular prism. Why is it a triangular prism? Well, because if you think the ends are triangles. This one, if it was to be made out of glass, you have a clear prism here. This is this kind of the thing that Isaac Newton used to discover that sunlight is made up of all the colors of the rainbow. He was in his lab in England, kind of shut the curtains, let a little bit of light through, had the sunlight go through this, and then he saw, the entire spectrum of visible light. So basically, you saw a rainbow. All right, now into our elective forms. So this is the hexagonal pyramid. Why? Because it has a hexagonal base, and it's got 6 triangular sides that, again, meet at an apex. This one, if you look on the screen, when this one is unfolded flat, it looks like one of the 4 stars on the Chicago flag. Next one is the octahedron. Well, the octahedron looks kind of similar to ones that we had. So let me find my square pyramid. Oh, here it is. So if I have my square pyramid, And if I have 2 of these, so let me go into my goodie bag of forms and find another one. So I've got 2 square pyramids. I put them square sides to each other. Oh, look, you make the octahedron. And the prefix octa means 8. Next one is a dodecahedron. This one is probably the trickiest one to assemble. If you look at the net on the screen, there's a lot of the dotted score lines. There's a lot of cut lines. So if you're making this one, be really careful when you do it. Watch the assembly video to give you some hints how to do it. The dodecahedron has 12 pentagonal faces. So all the faces are the same. They're all pentagons. The prefix dodec means 12. This is not a soccer ball. You know, a soccer ball, I think it's called an icosahedron or something like that. It's just got a lot of sides to it. And one thing, if you notice about this, it's starting to look more like a ball, like a sphere, because as each side gets smaller and we keep adding more and more of them, the whole figure itself gets a little rounder. Next one is the Pentagonal Pyramid. This one has a pentagonal base and then 5 triangular sides to it. This one, a lot of like turrets on houses. If there's a little turret, it's kind of like a round pointy part to the house. This is what the roof structure looks like. And the last one, the right rectangular prism. Yeah, it's a box. Well, no, it's a box. But it's called a right rectangular prism. Why? Because the ends, you have one here and one here, well, they're rectangles. So that's a tour of all the forms, all 10 of them, that you can use in your Structuring Streakahedrons kit. Then the YouTube videos on how to assemble them and the full instruction manual where all these slides came from are linked on the Steinmetz school website. If you go to the school website, right in the middle underneath the picture, you'll see a little icon that says STEAM, kind of, I think it looks like an atom or something like that on there. I can't remember right now because I'm talking to you. Go there and you'll see all the videos and all the links that you need. That's all for this lesson. I'll see you tomorrow.